So, water. We all know it's literally the foundation of life, right? But the way we actually interact with it, how we manage it and, well, deplete it, is full of these wild contradictions. In today's explainer, we're jumping right into the incredibly urgent and honestly fascinating reality of our global water crisis.
Here's the roadmap for today. We'll start with the blue planet paradox, move into the real roots of water scarcity, tackle the mega dam dilemma, and finally, look at traditional rainwater harvesting.
Okay, Section 1. The blue planet paradox. Water, water everywhere. I mean, it's a completely baffling mystery when you stop to think about it. From space, Earth is this giant blue marble, right? And the hydrological cycle is always running. Evaporation, condensation, rain, it's a perfectly renewable system. So if nature is literally recycling this stuff 24/7, how on earth are we running out of it?
Well, here is a pretty harsh reality check. A massive 96.5% of all our water is salty ocean water. That leaves just 2.5% is fresh water. And get this, roughly 70% of that tiny little slice, it's locked away in glaciers and ice caps. So what we actually have left for all of humanity's drinking, agriculture, and industry is just a fraction of a fraction, and most of that is hiding underground as groundwater.
The crazy part is, nature actually provides enough for our basic needs. But there's a massive difference between fulfilling a need and feeding a greed. Because we've overexploited this resource so badly, experts predict a staggering reality. Hundreds of millions, actually, some estimates say up to 2 billion people will face absolute water scarcity really, really soon.
Which brings us to Section 2, the roots of water scarcity. It's the shift from natural to human-made scarcity.
The really crucial thing to understand here is that scarcity isn't just about droughts anymore. It's this dual threat. On one hand, you've got quantitative scarcity, basically a physical lack of water. Our population is booming, which means we need more food, which leads to massive overpumping for agriculture. But then, on the flip side, you have qualitative scarcity. This is where the water physically exists, but it's completely unusable. Domestic sewage, toxic industrial waste, pesticides, they're all seeping in and turning perfectly abundant water sources into absolute health hazards.
Think about the quantitative side for a second. To feed everyone, we've vastly expanded agriculture, leaning super heavily into water-intensive commercial crops. And to water those crops, we've been drilling deep tube wells, totally overexploiting our underground aquifers. The result is the water table just absolutely plummets, leaving behind this cracked, barren earth. We are, quite literally, pumping our future dry.
At the same time, rapid urbanization is creating a whole different kind of strain. Even in cities that get plenty of rain every year, you'll see people lining up with plastic buckets around water tankers. Why? Because the sheer concentrated demand of urban populations mixed with industrial use just wildly outstrips the local, unpolluted supply. Everyone is pulling from the exact same shrinking and often polluted well.
Let's move to Section 3, the mega dam dilemma, or the temples of modern India. Now, before we really get into it, let's make sure we're on the same page. A dam isn't just a giant concrete wall. The true definition encompasses the entire barrier and the artificial reservoir or lake it creates behind it. It's a massive, massive intervention designed to completely control the natural flow of a river. When these huge, multi-purpose river projects were first championed, people saw them as the ultimate saviors. India's first Prime Minister, Jawaharlal Nehru, famously called them the temples of modern India. The vision was undeniably grand. These colossal structures were supposed to fast-track agricultural development, power huge industrial growth with electricity, and completely integrate rural and urban economies. But, keeping our explainer hat on, we have to look at the whole picture impartially. The advantages are definitely there, for sure. Dams provide vital hydroelectricity, year-round irrigation, and theoretically, they control floods. But the drawbacks are severe. They trap natural sediments, starving downstream aquatic life. The massive reservoirs submerge prime forests and agricultural land. And, ironically, actually this is kind of wild, because sediment builds up at the bottom of the reservoir over time, a sudden heavy rainfall can force operators to release excess water, triggering the exact catastrophic floods the dam was built to prevent. Plus, all this ecological friction sparks some really powerful socially grounded pushback. Look, when you build a megadam, the people living in the valley have to pack up and move. This led to massive movements, most notably the Narmada Bachao Andolan, or Save Narmada movement. Local indigenous tribes, farmers, and activists heavily protested the loss of their ancestral lands. The core argument here revolves around equity. Rural populations end up displaced, losing their homes, while urban centers and large industries reap the bulk of the water and power benefits.
So, where do we go from here? That brings us to Section 4, Traditional Rainwater Harvesting, Sustainable Wisdom from the Past. If we take a quick geographical tour of India's indigenous water management, you'll see some incredibly clever hyperlocal adaptations. Up in the steep Himalayas, communities built galls and khools to delicately divert stream water for their crops. Over in Bengal, they dug inundation channels to harness floodwaters. In arid Rajasthan, they developed khaddans and johads, these earthen structures that literally stop water from flowing away, letting it seep into the ground to keep the soil moist for the dry season. Oh, and in Meghalaya, they have a 200-year-old system using bamboo pipes to transport spring water over hundreds of meters, dropping it precisely right at the plant roots. Let's break down how one of the most famous of these systems works, the underground tanka used in semi-arid regions like Bikaner. It's so elegantly simple, yet so effective. Rain hits the sloped roof of a house, right? But instead of washing away, it flows through a dedicated pipe straight into a massive, room-sized underground tank built right inside the home or courtyard. Because it's stored underground, it's totally protected from the intense sun, so zero evaporation.
In Rajasthan, this harvested rainwater is deeply, deeply revered. They call it Palar Pani, and it's considered the absolute purest form of natural drinking water you can get. And as a completely awesome side bonus, these underground tanks act like a natural air conditioner. They actively cool the rooms built adjacent to or right above them during the scorching summer heat.
And I really want to emphasize this isn't just a history lesson. It is a highly viable modern solution. Take Gendatur, a rural village in Karnataka, where citizens just took matters into their own hands. 200 households independently installed these rooftop systems, and now they're harvesting a combined 100,000 liters of water every single year. Recognizing this potential, the state of Tamil Nadu actually became the first and only Indian state to make rooftop rainwater harvesting legally mandatory for all homes, complete with strict penalties if you don't comply. So, as we wrap up this explainer, the data really leaves us with a provocative thought. In our relentless high-tech rush to engineer nature with giant concrete walls and deep drills, might the simplest, community-driven traditions actually be our greatest tools? By just catching the rain where it falls, we might just find the most powerful way to save our blue planet. Thanks so much for joining me, and keep questioning how we interact with the world around us.